I'm going to do something different in this episode. No slides, no cuts, just this one map for the next 30 minutes.
Digital transformation time. Digital transformation time.
Because this single diagram contains the entire journey your product takes from an idea to something you build, ship, and support. And almost nobody has ever seen the whole thing at once. They see their piece. The engineer sees the left side. Purchasing sees one branch. The service team sees the far right. Today we're going to walk the entire map together, slowly. And by the end, you'll understand not just what each stage is, but where your time actually disappears, and which part you're allowed to compress, and which parts will end company if you touch them. Let me give you the shape of it first, then we'll go region by region. Left to right. Requirements, the design in CAD, then a chain of bill of materials, engineering, manufacturing, supply chain, a bill of process running alongside, and finally, the service view, which loops back to where we started. 7 regions. In a big company, each one is a department with walls around it. That's the secret the map reveals. The stages aren't the problem. The walls between them are. Keep your eye on the gaps between the boxes. That's where the whole episode lives. Before we walk it, one lens that makes everything else make sense. Look at the whole map and notice there are two completely different things flowing through it. The first, in green, is control. The requirements, the approved baselines, the traceability links, and the evidence. This is the stuff that lets you prove what you built and reproduce it. The second, in red, sitting in the gaps between the boxes, is handoffs. The waiting, the re-explaining, the sign-off that takes 3 weeks to schedule. Here is the thing almost everyone gets wrong. When they try to go faster, they cut green. They skip a review, drop a baseline, lose a link. And they fail an audit or ship something they can't rebuild. The entire skill of running a lean engineering operation is learning to see those two colors separately. You cut red, you never cut green. Hold that image, we'll come back to it on every single region. Region 1, requirements. This is where you state what the product must do, and crucially, what you'll have to prove. I've done a whole episode on why requirements are a control system, not documentation, so I'll be brief. But notice where they sit on the map, at the very start, feeding everything. Every green line on this entire diagram ultimately traces back here. If this node is weak, vague, untestable, unowned, every region downstream inherits that weakness, amplified. A fuzzy requirement on the left becomes a failed verification on the right, months and a fortune later. Now watch the link from requirements to cut. This is the first handoff on the map, and it's where the first quiet failure happens. In a world organization, requirements get thrown over to design. The engineer interprets them, makes assumptions, and starts modeling. If that link is thin, if the engineer doesn't deeply understand the intent behind the requirement, the design drifts from what was actually needed. And nobody notices until much later. The green that should flow across this link is traceability. Every design choice connected back to the requirement that justifies it. When that's present, if that link is thin, if the engineer doesn't deeply understand the intent behind the requirement, the design drifts from what was actually needed, and nobody notices it until much later. The green that should flow across this link is traceability. Every design choice connected back to the requirement that justifies it. When that's present, you can always answer why is the product like this. When it's missing, your CAD model becomes a pile of decisions no one can explain. The CAD node itself is where geometry, parts, and assembly structure gets decided. It feels like the real engineering, and it's where most companies pour their attention. But notice on the map how early it is. Decisions made here cascade across every region to the right. A part chosen in CAD with a 20-week lead time doesn't reveal its cost until you're 4 regions away in supply chain. That's why the experienced move, which we'll get to, is to pull downstream knowledge leftward into this node before the cascade starts. Now we reach the heart of the map and the place where more time and conflict lives than anywhere else. From the CAD design comes the EBOM, the Engineering Bill of Materials. This is the as-designed view, every part and assembly, the way engineering thinks about the product. It answers what is this thing structurally by design. Clean, logical, organized the way an engineer's mind works. And then look at this gap on the map. I've drawn it wider than the others on purpose. The EBOM has to become the MBOM, the Manufacturing Bill of Materials. This is the as-built view, the same product but reorganized entirely around how you actually make it. And here is what trips everyone up. The MBOM is not just the EBOM rearranged. It contains things the EBOM has no concept of: consumables, process materials, packaging, the assembly sequence structure, and the part substitutions the shop floor needs. An engineer designs a product. A manufacturing person builds a process. They are describing the same object in two different languages. And this gap is where those languages collide. Why does this gap eat so much time? Because in a world company, it's a literal handoff between two departments who think differently and often don't talk. Engineering finishes the EBOM, throws it over, and manufacturing comes back weeks later with "we can build it this way" or "the structure doesn't." Then it goes back. That round trip, design, reject, redesign, can repeat several times. On the map, that red arc pulsing back and forth across the gap is your calendar bleeding out. Now, I want to go deeper than most people ever do on this gap, because there is a layer underneath it that explains why so many expensive PLM projects fail to fix it. Oleg Sholovytsky, who has written the Beyond PLM blog and analyzed this industry for 2 decades, makes a sharp point, building on Professor Jörg Fischer's work, that the EBOM to MBOM problem isn't really about structure at all. It's about semantics, meaning. Look at this little inset I've put over the gap. The same object means different things in different systems. What engineering calls a part in PLM might be a material or an SKU in your ERP. A phantom assembly, a grouping engineers use that has no physical existence, exists in one system, and is meaningless in another. So when companies try to convert the EBOM into the MBOM with automated rules, it works for the simple cases and then shatters on these semantic mismatches. You're not translating a structure. You're translating meaning between two worldviews, and rules alone can't carry meaning. And here is the part that should make you a little angry. Shilevitsky points out that a lot of this fragmentation isn't a law of nature. It's a business model. Enterprise vendors build their products to lock each piece on its own system. The EBOM lives in PLM, the MBOM in ERP, the service BOM in yet another platform. And they monetize the boundary between them. So part of the reason this gap on the map is so painful is that someone profits from it staying that way. You are paying in calendar time and reconciliation effort for somebody else's license strategy. So, what's the actual fix? Not a better conversion script. It's keeping a connected, shared model where the EBOM, MBOM, and supply views are linked representations of one source, not separate copies you reconcile by hand. The goal in Shilevitsky's framing is one structure with different views, not five bombs that drift apart. On our map, that means this whole central region should ideally be one connected thing you view different ways, not a series of walls you throw documents. The goal in Shilevitsky's framing is one structure with different view options, not five bombs that drift apart. On our map, that means this whole central region should ideally be one connected thing you view different ways, not a series of walls you throw documents over. Keep that ideal in mind. We'll make it concrete when we talk compression. Now, follow this branch dropping down from the center, the supply chain bomb. This is the view purchasing and your suppliers work from. What's bought, from whom, lead times, alternates, cost. Notice I've drawn it as a branch, not as the next box in the line, and that's deliberate. In reality, supply chain considerations don't politely wait their turn after the MBOM is done. They should be pulling on the design from early on, because supply chain reality is where beautiful designs go to die. Here is the classic failure, and you can trace it on the map. The engineer, working in isolation on the left, designs a part. It's elegant. It flows right through EBOM towards MBOM. Then it hits the supply chain branch, and only now does anyone discover the part that has a 20-week lead time, or a single supplier on another continent, or a price that wrecks the margin. So that red line shoots all the way back to cut. Look how long it is. The longest return path on the whole map, and the design changes. All that work to the right of cut just got invalidated. The further right a problem is discovered, the more expensive the journey back. The green here, the control, is knowing your true source in reality and keeping it linked to the design. The red, the handoff, is the wall that makes the engineer discover source in reality weeks too late. Remember that distinction. The compression move for this branch is one of the highest value plays in the whole episode. Running alongside the MBOM, see how I've paired them on the map, is the BOP, the bill of process. If the MBOM is what the product is made of for manufacturing, BOP is how it is made. The sequence of operations, the routing on the shop floor, the work instructions. The MBOM is the cast of characters. The BOP is the choreography. They're partners, and on a healthy map, they're developed together. The common mistake is treating the BOP as an afterthought, something you write once the MBOM is frozen. Watch what that does on the map. The design and the manufacturing structure get locked, and only then does the person who has to actually assemble it get a say. And of course, they find problems. A part that can't be reached by a tool, a sequence that requires 3 hands, a step that's unsafe. Now you're changing a frozen design to accommodate a process concern that could have been raised at the start. More red across the gap. The fix, which we'll detail shortly, is to give the process voice and alias it. To develop the BOP concurrently, not sequentially. The fix, which we'll detail shortly, is to give the process voice and alias it. To develop the BOP concurrently, not sequentially. Green here is the routing and work instructions being correct, controlled, and traceable to the baseline. Because in regulated work, how something was built is a part of the evidence. Red is the wall that makes process thinking arrive too late. Same pattern as everywhere on this map. We've reached the far right, the service bomb. This is the product's life after you ship it. What's maintainable, what's a spare, what gets replaced in the field, often for years or decades. In a lot of companies, this is an afterthought bolted on at the end. But look at the map. There is a loop from the service bomb all the way back to requirements. That loop is the point. What you learn in service, what fails, what's hard to maintain, what customers actually need, should feed back into the requirements for the next version. The life cycle isn't a line that ends at shipping. It's a loop. And here is the subtle thing that map teaches. Serviceability is decided on the left, even though it's experienced on the right. Whether a product is easy to maintain is determined by design choices made way back in CAD. If nobody's thinking about the service bomb while designing, you ship something that's a nightmare to maintain. And you only find out years later when it's far too expensive to change. The green thread that should run the full width of this map is design decisions linked to their lifecycle consequences. The whole point of seeing the entire map at once is that you stop optimizing one region while quietly sabotaging another. Now we've walked the whole map, and you can see the pattern. The boxes are fine. It's the red on the gaps that costs you. So let's go back through and at each gap show the move that collapses the handoff without touching the control. 6 moves. Watch where each one lands on the map. Add the requirements to CAD link. Tightly couple requirements to CAD by driving master skeleton models via configuration-controlled global variables. Enforce bidirectional PLM to CSML synchronization. And for advanced level, you can embed unique requirement UUIDs directly into the CAD feature tree metadata attributes. At the big central gap, don't make it a wall. Collocate engineering and manufacturing thinking so the EBOM is born manufacturable. The design for manufacture check happens during design, not after it. The widest gap on the map gets half closed before it even opens. On the supply chain branch, sit engineers and buyers together, literally the same flow. So as the design is forming, sourcing reality is already in the conversation. That 20-week lead time discovery happens while the design is still soft and cheap to change, instead of after a long journey to the right. This is one of the highest value moves on the whole map, because it kills the longest red return path. At the MBOM BOP pair, develop them concurrently. Give the person who'll assemble it a voice while the design is still soft. Process problems surface early, not against a frozen baseline. Across the whole central region, keep one connected BOM backbone instead of rekeyed copies. The Shilevitsky's principle. One structure, many views. A change propagates instead of being retyped 3 times. This is the digital thread doing real work, and it's what makes the connected ideal we discussed actually real. And everywhere there are sign-offs. Replace sequential multi-week approvals with one small standing cross-functional group that can actually decide. The decision still gets made and recorded. That's green, that's control. It just stops waiting 3 weeks for 5 signatures. That's red. That's the handoff you kill. Step back and look at the whole map now with all 6 moves applied. Notice what we did. We never removed a box. We never cut a green line. We collapsed the red on the gaps by moving knowledge earlier, putting people in the same room, connecting the data, and deciding in one place. Same rigor, a fraction of the calendar. That's how 3 people do what used to take 50. But before you go compress everything in sight, the other half. because compression has a cliff edge, and the map shows you exactly where it is. Light up every green element now. The requirements on the left, the traceability links running across, the baselines at each frozen point, the evidence trail, the verification and validation. This you never cut. Not when you're lean, not when you're in a hurry, not ever. The test is simple and it's visible right here on the map. If removing something only removes red, waiting, a redundant handoff, a rekeyed copy, cut it. If removing it removes green, a link, a baseline, a piece of evidence, you just bought a future catastrophe on credit. An auditor doesn't care that you were efficient. They care that the green is intact and you can prove it. So here is the whole episode on one map. Your product flows left to the right. Requirements, design, the engineering and manufacturing and supply bombs, the process, the service view, and loops back. Two things travel that path: control, which you protect with your life, and handoffs, which you compress without mercy. Big companies build this map for armies, with a wall at every gap. A small team wins not by skipping regions, but by tearing down the walls between them while keeping every green line intact. Cut the red, never cut the green. Learn to see those two colors separately, and you can run an audit-grade operation with a fraction of the people. That's the entire game, and now you can see all of it at once. I'll see you in the next one.
Digital transformation time. Digital transformation time.